Hello, my name is Anastasia Masalva, and this is my lab report on the topic of the black hole. The main goal for the third lab is to find the mass of the given black hole by using the momentum principle and predict velocity of a particular space object for specific movement. The experiment is important for us because it helps to understand how objects move in space. Additionally, analyzing motion of different space objects shows how objects move under gravitational force only. Before I elaborate on the lab and the results, I want to cover several concepts and formulas that we will need for analyzing the motion. Newton's second law or momentum principle is the main concept for this lab. In the experiment, we consider the net force to be equal to the gravitational force only. On the screen you can see the formula we use to compute gravitational force. From the momentum principle, I derived the formula for the mass of the black hole. For the lab, we also need to know the velocity update formula and the position update formula. To complete the first part of the lab, I had to modify several lines in the glow script starter code. First, I changed the star mass to the one given in the lab instructions and time interval to the number of seconds in 1 day. After that, I modified initial and final momentum vectors using the formula for the momentum, which equals to the mass multiplied by the velocity. Knowing these values, I found change in momentum and then the net force using the formula net force equals to the change in momentum over change in time. After that, I calculated perpendicular and parallel components of the net force and found the mass of the black hole for each iteration in the while loop using the formula I derived before. After the while loop, I found the approximate mass of the black hole by dividing the sums of masses in each iteration by the total number of iterations. After modifying code in GlowScript, I ran the program and observed the motion of the planet on the trajectory around the black hole. To complete the second part of the lab, I had to modify several lines in the new GlowScript starter code. First, I changed the black hole mass to the one I got from the first part of the lab. After that, I predicted the initial velocity of speed and its components on OX and OY axis. Then I calculated gravitational force on the planet by the black hole and the spaceship, and on the spaceship by the black hole and the planet. Knowing these values, I found the net force acting on both the planet and the spaceship and calculated the position over time. After writing code in GlowScript, I ran the program several times and observed the motion of the planet and the spaceship. I had to modify the initial velocity of the spaceship several times to reach the target trajectory when the spaceship gets close to the black hole without crashing on the planet or the black hole. After conducting the experiment, I needed to give answers to two questions. The first of them asks how the net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular components. The answer is simple. There is no difference because of the net force components are exactly equal to the components of rate of change of the momentum according to the second Newton's law. The second question asks to predict the initial velocity of the spaceship for it to move in the orbit around the black hole without crashing on the planet or the black hole. To find the answer to this question, I modified the initial velocity of the spaceship and observed its motion. I found that the velocity was 0 meters per second as an x component and 1.2 multiplied by 10 to the power of 7 meters per second as a y component makes the spaceship move in a circle-like trajectory around the black hole. Thank you so much for watching this video. I hope to see you in my future labs.